Good morning, students. This is Bhaktavachala, Associate Professor and Head of the Department of Electrical and Electronics Engineering, PBR Viswadaya Institute of Science and Technology, Kavali. So in this semester, I am going to deal the power semiconductor drives for Thought BTech second sem students. So in earlier class, we discussed about what is the syllabus in the power semiconductor drives. Simply it consisting of 3 units DC drives and 3 units AC drives. Yes. So you see here, the power semiconductor drives consisting of the first 3 units belongs to DC side and the remaining 2 units belongs to AC side. So let us have in unit number 1, the converter pad DC motors. So the syllabus belongs to the converter pad DC motors. So here simply consisting of the basics of the electrical drives and followed by the single phase and 3-phase semi and fully controlled converter pad, DC separately excited and DC series motor drives in the continuous current operation, and the analysis of output voltage and current waveforms, and the speed and torque expressions and speed and torque characteristics are going to be discussed in this unit. So the unit number 1, 2, 3 purely belongs to DC. And in all the 3 units, we are more familiarly using the DC separately excited motor and DC series motor. In this regards, let us have a look at what's the basic equations as well as the characteristics of DC separately excited motor as well as series motor. Let us have a look on the basic characteristics of DC separately excited motor here. Yes. So the equivalent circuit of a separately excited motor. Generally, the separately excited motor has a field circuit as well as the armature circuit. So the equivalent circuit of separately excited motor, just you see here how it is to be designed. This the equivalent circuit of DC separately excited motor. It consisting of a armature circuit as well as the field circuit. So in field circuit is excited by field voltage VF and armature circuit is excited by armature voltage VF. Yes. So as long as VA and the VF are excited, obviously the motor rotates and develops a back EMF and producing a torque. Yes. Yes. So the shaft of the motor is coupled to an external load. So the motor is producing a motor developed torque TD and the speed of omega. And the external load having the inertia in terms of J, that is the moment of inertia, and the friction, that is the B, friction is friction constant, and similarly the load torque TL. So the load torque TL always against the motor torque, always against the motor torque. Yes. So as per this circuit, let us frame some dynamic analysis of this particular drive. So in this regards, the equations describing the characteristics of separately excited motor from the figure. So let us see the loop equation of the field circuit. It is the VF is equal to IFRF plus LF DIF by dt. So the LF DIF by dt is the time derivative. And similarly, you can make the instantaneous armature current equation. Armature current can be found from the loop equation of the armature circuit. So that is the VA is equal to IARA plus LA DIA by dt plus EC. EC or EB. In motor, particularly you call it as a back EMF EB. Yes. So similarly, the motor back EMF. Yes. So the motor back EMF, it is also known as the speed voltage, and this can be expressed as, so EC is directly proportional to speed and flux. So this is the basic generated EMF equation of the DC motor. Yes. So EC is directly proportional to speed in field current. So here the proportionality constant is KB. So it is the voltage constant. And the developed torque can be expressed as it is the TD is equal, TD is directly proportional to IA into IF. So here TD depends upon the magnitude of armature current as well as the field current. So here KT is the proportionality constant, which is in terms of torque constant. Yes. And the developed torque must be equal to the load torque. Then only the load will be rotating along with the motor. So that can be expressed as TD is equal to J d omega by dt plus B into omega plus TL. So where TD is the motor developed torque, which is equal to the J d omega by dt. This one is known as the dynamic torque, and B omega is the friction torque, and TL is the original load torque. So all these equations are represented for dynamic system, and the same values can be expressed for steady state values. See here, under steady state conditions, all the time the derivatives in these equations are going to be 0. Yes. So let us see how the equations are to be represented. So VF is equal to IF into RA. So this LF dIF by dt is the time derivative, which is equal to 0. Yes. And similarly, the EZ is the back EMF or generated EMF, which can be expressed as usually kV into omega into IF. And similarly, VA can be written as VA equal to IA RA plus EZ. So because the time derivative of LA dIA by dt is equal to 0, and substitute the EZ value in this equation. So this becomes the VA is equal to IA RA plus kV into omega into IF. And similarly, TD is equal to, after the dynamic torque has to be 0 because of the steady state condition, the time derivatives are 0. TD is equal to B omega plus TL, which is also equal to KT into IF into IA. Yes. And the developed torque is TD, it is the KT into IA into IF. That can be expressed in terms of the power developed. Power developed is equal to the TD into omega. Yes. So P is equal to T into omega. Here TD is the developed torque and omega is the angular velocity in radians per second. And the speed of a separately excited motor can be found from the previous equation. So that is the VA is equal to IARA plus KV into omega into IF. From this equation, omega can be isolated here. Omega is equal to VA minus IARA divided by KV into IF. So here, VA minus IARA is the voltage across the armature and is the numerator, and KV into IF is a denominator. While writing in the notebook, you should be use it is a divided by. Yes. So as per this equation, we can conclude that the voltage across the armature is directly proportional to the speed, and the field current is inversely proportional to the speed. Yes. So here field current can be also expressed as VF by RF. So from this equation, the speed of the motor can be varied by two methods. One is the armature control method. Yes. So because the voltage across the armature is directly proportional to the speed, this is the armature control method. Second one is the field control method. So in field control method, the speed is inversely proportional to the field current. Yes. So another one is torque demand. To maintain the torque constant, and the IA and IF both to be fixed and maintain the torque constant. And similarly, these methods, the armature control method and field control methods, are particularly developed for the below rated speeds as well as the above rated speeds. Let us see here. For speeds below the base speeds, IA and IF are maintained constant to meet the torque demand, whereas VA is varied to control the speed. That means that in armature control method, field is kept constant and armature voltage alone is to be varied to control the speed of the system. And similarly, for speeds above the base speeds, definitely you can go for the field control method, whereas speeds above the base speeds, VA is to be maintained constant and the field current is varied to control the speed of the system. Yes, and the corresponding basic characteristics such as the developed torque TD and the power developed PD, armature current, and field current versus the speed. You can observe here. So there is a one y-axis, which is the developed torque TD and power developed PD, and armature current IA and the field current IF. And there are two plots here. This is the one x-axis speed in terms of angular velocity. This is the another speed in terms of angular velocity. So these four parameters versus speed in the constant torque region and constant power region you can draw. So let us have a look on what is the constant power region. Yes. So in constant power region particularly, torque is directly proportional to IA and IF. So to maintain the torque constant, the armature current and field current both are proportional to each other. Torque and armature current and field current both are proportional to each other. So that to maintain the torque constant, remaining the IA and IF both should maintain constant. So that is the reason in constant torque region, to obtain the characteristics in constant torque region, the TD should be maintained constant. TD should be maintained constant. Yes. So why? Because the to obtain the characteristics in constant torque region. In this regards, the torque is to be maintained constant. Torque is constant. Torque is directly proportional to IA and IF. IA and IF both will maintain a constant value, but the value of the IF is very small compared to that of the order of the armature current. Field current hardly not more than 1.5, 1.6 amperes. But whereas armature current is in terms of 8 amperes to 10 amperes, like that per 5 kilowatt DC motor. Okay. So you see here, torque is maintained constant, armature current is maintained constant, and field current is also maintained for getting the constant torque region. Yes. So whereas you see here from the PD is equal to TD into omega, the speed and power both are directly proportional to each other. That means that they should maintain a linear relation. That is the reason the power is to be linearly increases along with the speed, along with the speed you see here. Okay. So these are the nature of the four characteristics: TD, PD, IA, IF in the constant torque region. Whereas you come for the constant power region, to maintain the power constant, to maintain the power constant along with the increase in speed. So the armature current should maintain constant and power should maintain constant, but the speed and torque are inversely proportional to each other. As the torque increases, speed decreases. Otherwise, speed increases, torque decreases. So as per this, the power is PD constant, and to maintain the power constant, armature current is maintained constant, and the torque is inversely proportional to the speed, resulting the torque is decreasing along with the field current. Yes. So this is the basic characteristics of DC separately excited motors. So similarly, we have a basic characteristics and equations belongs to the series motor. Let us have a look on what is the series motor, and when we prepare the series motor, particularly when high torques are required in terms of the output power, the series motors are to be preferred. So the equivalent DC series motor as shown. So the field of the motor is connected in series with the armature. That is the reason such type of motors are known as the series motor. And the equivalent circuit of the series motor, simply see here. So what it has, this one is the armature circuit, armature winding. This one is the field winding. So the armature winding and field winding both are connected in series with the armature. That is the reason this is known as a series motor. Here IA and IF both are equal. IA and IF both are equal, and this can be excited at a voltage VA. So the field will release its own flux, so the armature will release its own flux, resulting the motoring action is to be taking place due to the interaction of the two fluxes. And once the motoring action is to be taking place, and it produces a back EMF EB or EC. So the shaft of the motor is coupled to an active load. The motor speed is omega and the motor torque is TD, and the load torque will always oppose the motor torque. And along with the motor torque, the friction constant, the moment of inertia, everything is to overcome. Then only the external load is to be rotating along with the shaft, along with the motor. Yes. So this is the simple equivalent circuit of a DC series motor. And now here also you have to be obtain the equations belongs to the DC series motor under steady state. We can't write any dynamic equations here. We are simply representing the steady state quantities. Yes. So as usually, this is the familiar equation, the back EMF or generated EMF, which is directly proportional to speed and field current. But here field current and armature current both are same. So EZ is equal to kV into omega into IA. And similarly, VA is equal to this the armature voltage. So IA into RA plus IA into RF. This can be right RA plus RF into IA plus EZ, but EZ has a LU of KEV into omega into IA or IF, both are same, IA or IF. And from this, the output torque TD is equal to KT into IA into IF as per the equation of torque. And similarly, this is also equal to B omega plus the TL, B omega plus TL. So why? Because the time derivatives all have to be suppressed here, because under steady state, the time derivatives are coming to zero value. Yes. So the speed of a series motor can be given by as per the armature voltage equation. So in this equation, it should have a omega. To isolate the omega, it is the omega equal to VA minus IA into RA plus RF divided by KV into omega. So as per this equation also, we can conclude that the speed of DC series motor can be controlled in two manners. One is the speed is directly proportional to voltage across armature. Another one is the speed is inversely proportional to the field current. So let us conclude those methods. The speed of this series motor can be controlled by using one is the armature control method. Already we discussed in the separately excited motor, right? So armature control method is exclusively designed for below rated speed. And similarly, field control method is designed for above rated speeds. And this one is also same to the above one. It is the armature current, which is measured of the torque demand. So to maintain the torque constant, so armature current should be maintained constant. Yes. So the characteristics of the series motor as shown here. Yes. So you see here, and there are four parameters. One is the power developed, another one is the torque developed, and another one is the armature current, another one is the field current. These four parameters versus the speed we need to draw. So in those four parameters also represented in two regions. One is the constant torque region, another one is the constant power region. So in the series motor particularly, armature current is equal to field current. That's the reason we are taking only one current here. Yes. So in constant torque region, you see here in constant torque region, in particularly constant torque region, to maintain the torque constant, no doubt in this. And to maintain the torque constant, obviously torque is directly proportional to the armature current and field current. So current should be also maintained constant. But as per the power developed equation, P is equal to T into omega. So omega, and that is the speed and power, is directly proportional to each other. That means they are maintained a linear relationship with the speed. So therefore, the speed and power, those two are linearly varying. So these are the three characteristics in case of the constant torque region. So similarly, you can observe in the constant power region. So the power should be maintained constant. Power should be maintained constant. So power should be maintained constant. And what about the torque? In the sense, torque has to be decaying, because the speed increases. The speed torque increases, speed decreases. Speed increases, torque decreases. This is the relation here. Yes. So to maintain the power constant, what's the nature of the armature current here? Armature current is also decreasing along with the torque TD. Yes. So to maintain the power constant. So these are the characteristics. So these are the characteristics of DC series motor. And so therefore, we can conclude this topic So the basic characteristics of DC separately excited motor, the basic characteristics of DC series motor in the constant current as well, sorry, constant torque and constant power regions are discussed. So these two drives are helpful in the first, second, and third unit because we much concentrated on these drives only. Okay, thank you. So we will start the actual content of the syllabus in the next class onwards. Yes. So thank you all of you.